which is found in many vacuum cleaners and angle grinders. My vacuum cleaner broke down, so I had to figure this out. And now you can desolder the TRIAC from the board. Finally, the TRIAC is removed. The model of the TRIAC here is BTA12 600B. This is a common TRIAC and is mainly used in vacuum cleaners and angle grinders. A TRIAC is a semiconductor device that is a type of thyristor. It is used for switching in AC circuits and is often used instead of a relay. It is silent, switches on quickly, but operates at high temperatures and voltages, which is why it often fails. So let's figure out how to test it. A TRIAC can be tested in two ways: using a multimeter or a special device, or with a regular light bulb. I will show two methods. First, let's test it with a multimeter. We find the pin configuration of our TRIAC on the internet or in reference literature. In my case, the anode, cathode, and gate are located from left to right. They are labeled A1, A2, and G. Set the multimeter to the diode test or continuity mode. It is located in this position. The number 1 appeared on the display. Let's start the test. Now measure the resistance between the A1 and A2 contacts. It should be infinite, which means 1. This means it is functioning properly. Now it is necessary to measure the resistance between A1 and G and A2 and G. Between A1 and G, there should be a small resistance, approximately 50 to 100 ohms, and there should be no connection between the A2 and G contacts. The resistance should be infinite. Then take a regular battery or an accumulator with a voltage of 1.2 to 1.5 volts. Connect wires to it using alligator clips or another method, like this, and apply this voltage to the TRIAC. Connect the two leads K1 and A2 and attach the power to the control electrode. Now the resistance has sharply dropped and it's almost a short circuit. So A1 and A2 are connected. When I remove the voltage, A1 and A2 close again, because this voltage is insufficient to maintain the circuit. There must be a good holding current. You can swap the tester probes because the current should flow in both directions. Swap the probes and it's clear that nothing has changed. The current flows in both directions equally. Thus, checking with a multimeter is good, but for greater accuracy and assurance, and also if you don't have a multimeter, you can check with a light bulb. We will need the same battery or an old phone charger. It provides 5 volts and will be perfectly suitable, and also a regular light bulb that can handle these 5 volts. I soldered 2 wires to the light bulb, and now these wires need to be connected to the blue negative from the power supply. Then I also attach the negative wire to the bulb's lead with a crocodile clip, and all this setup can be connected to our TRIAC. Connect the red wire to the A1 terminal and the black wire to the A2 terminal. This is the negative. The light bulb is not lit yet. Then using tweezers, short the central and control electrode. The light bulb lit up. Now, short the 2 electrodes together, A1, A2, and the light bulb goes out. Let's repeat once more. If you short the control electrode with the A1 electrode, there will be no reaction. For clarity, I will show a faulty TRIAC that does not respond to these actions. There is a flash, and that's it. This TRIAC is faulty and needs replacement. Thus, you can check the TRIAC's functionality at home. However, major faults in the TRIAC can be identified. All that's left is to buy a new TRIAC, solder it onto the board, apply thermal paste, and attach it to the cooling radiator. To replace the old BTA12 TRIAC, I found a more powerful BTA16. It has a higher current reserve. Now, take a non-drying thermal paste like KP19 and apply a thin layer to the back of the TRIAC. Wipe off the old thermal paste from the cooling radiator. And you secure it onto the board and the TRIAC. And we tighten the bolt, securing the TRIAC to the heatsink. We plug the vacuum cleaner into the power outlet and try to start it. Thus, I identified the malfunction of the TRIAC. This was the main breakdown of the vacuum cleaner.